What's up, my mathletes? This is Mr. Muscarella coming at you. And in this video, we're going to take a look at right triangles and three of the trig functions you may not have learned yet. And they are secant, cosecant, and cotangent. So you already know sine, cosine, and tangent from geometry. Now we're going to kick it up a notch and add in there the other three trig ratios for right triangles. So go ahead and get your notebooks ready. Get your notes out and make sure that you also have your formula sheet ready to roll. Because on that formula sheet, you're going to need to write down all of these formulas. All of these formulas. So again, some of these should be very familiar to you already with sine, cosine, and tangent, and the acronym that you used in the past, SOHCAHTOA. You know, that was something that a lot of times teachers will give you to help you remember the three trig ratios, sine, cosine, and tangent. Now, their reciprocals are cosecant, secant, and cotangent. So when you look at the opposite side and hypotenuse for sine, whatever that ratio is, its reciprocal ratio is going to be cosecant. And so the O and the H, they switch locations. Your numerator becomes your denominator, and the denominator becomes your numerator. So there's two different sets of formulas there. So please take a moment and write those down. Write those down, and then pause the video, write it all down, and then come on back when you're ready. Alrighty now, welcome back. Alright, so one thing to really pay attention to is this idea of location. Location is so critical when we're working with angles on sides of a triangle. So if our reference angle is right here, then that means the opposite side will always be across from it. In the triangle on the right, the reference angle is in the top, which means the opposite side is across from it as well. But please be careful to make sure you pay attention to where the location is. One common mistake people will make, and it happens more when their reference angle is in the top of a triangle, they'll incorrectly label the hypotenuse as the adjacent side. So be careful, don't incorrectly do that. Just take your time and you should be okay. Now this y and r, this x, y, and r that you see in each one of these sections right there, that's going to come into play later when we take a look at the unit circle. And so I want you to kind of put those in there now because we'll refer back to them later. All right, now we're going to go through 4 examples together. And so we're going to take these first two right here. So take a moment, pause the video if you need to not only write down the problems, but also to draw the pictures. Now, this first problem, number 1, asks us to find cosecant. And cosecant is going to be the relationship of the hypotenuse and the opposite side. So the very first thing that you should do when you look at this is identify where theta is, the angle, and then look for the 3 sides, opposite, adjacent, hypotenuse. So opposite side is going to be right here, across from theta. Now again, be careful. Here's your hypotenuse right here, and the adjacent is going to be the side that has 6. So that's always the very first thing to do as you start to work with these kind of problems. Now some people might need to write down the letters for it. Cosecant is going to be the side that is the hypotenuse over the adjacent. So if you need to write that down, that's cool. If you can skip and go right to here, 2 squared root of 13 over 4, if you can go ahead and write those down. Well, I'm sorry, I wrote hypotenuse over adjacent. Ha! I was thinking hypotenuse over opposite. So if you need to write down 2 squared root of 13 over 4, you go right to there, and you forget to write the H and then the O or the hype and the OPP, that's fine. But don't forget, just be careful. Make sure that you reduce, so you would end up with square root of 13 over 2. And that's it. So to find cosecant, again, you just got to make sure you pick the right 2 sides, write down the ratio, and reduce if you need to. Now let's take a look at example number 2. Example number 2 is asking us for secant. So secant, that is going to be the relationship. And again, if you don't have the formulas memorized yet, that's cool. That's going to be hypotenuse over adjacent. So see, I was thinking ahead before. So that's hypotenuse over adjacent for secant. Now again, I'm going to label all 3 sides. So where theta is, my opposite side is over here. My hypotenuse is right here. And I usually label the hypotenuse first before I label the adjacent, because in that way I won't mess up the adjacent side. So those are my 3 sides, and the 2 that I need for this ratio of secant I already got them. So that's cool. So, ha, I got you. So 17 over 15, I can't reduce it. Boom, diggity, done. Now, I'm going to throw a curveball at you, though, because we're going to do other problems like this. So say I ask you to find the tangent of theta. Aha! So tangent, you know that's the ratio of opposite over adjacent. Now, the opposite side, I don't know that yet. But I do know my adjacent side is 15. So I need to figure out what that other side is, that missing side, in order to find tangent. So, who do we use? We call on our old buddy Pythagoras. And Pythagoras was a really cool dude who went to China, did some exploring, and hung out and learned a whole bunch of cool math things and brought them back to Greece, where he then published some of that stuff. And one of those things was the Pythagorean theorem. So even though he didn't discover it, he got it published in the Western world, because Greece was considered the Western world back then, and he wrote it down. So you don't have to write down what the actual Pythagorean theorem formula is. A squared plus b squared equals c squared. Later on in some other courses, and part of this one, you're going to work with x squareds and y squareds and r squareds, where x and y are going to be your xy coordinates, and r is going to be the radius of the vector or of the unit circle. So we'll talk more about that later. But you can skip that part. But what I do want to emphasize is that you take your time and you write things down neatly and organized. So the a squared and b squared, it doesn't matter which letter you let 15 go in for, a or b. Doesn't matter. C, though, has to be the 17. I want you to put parentheses around that, and you'll see why in a little bit. A squared, I'm just going to let 15 be the a squared. If you let it be b squared, it's all good. Doesn't matter. Now, when you square 15, you get 225. B squared is what we're trying to figure out, and 17 squared is 289. When you do your subtracting, now again, you guys are not in Algebra 1, so I don't want to see subtract 225, subtract 225. You're going to do that mentally, or just write your answer on the next slide, and that will be 64. Now, Algebra 2 stuff coming at you here, don't forget, plus and minus when you square root 64, and you guys are at a level where you know the square root of 64 is going to be 8. So I have two possible answers, 8 or negative 8. One of them will work, and one of them will not work for this particular triangle. In this case, our b value is going to be positive 8. So my tangent ratio would be 8 over 15. Now, when would it be negative 8? I'm so glad you asked. So later, coming up shortly, we're going to take a look at, we'll be given a value around the unit circle. We'll be given a point, or we'll be given some information. And on that information, we would end up having to draw a triangle, and that triangle might look like this, where you have the 15 here and the 17 there. Now, based on, and then theta, of course, would go right there. The theta, and then we'll be doing this later on, but the theta is always going to go closest to the origin. So, you know, more on that later, but you won't draw theta over in that spot. That's furthest away from the origin. The other thing is the right angle will always be drawn on the x-axis. So, setting the table for something we're going to eat later on. Now, 15 and 17, when we roll through our Pythagorean theorem, this is one where this coordinate right there, the y-coordinate in that quadrant, is negative. So this is one where your answer would be negative 8. All right, so more on that later, but we'll play with those ideas coming up soon. But we want to get these other pieces down first before we stick a coordinate grid on it. So that's coming later. All right, coolio. So that's number 2 for you. So I know we threw like 2A in there to give you a little bit with tangent, because we're going to do that stuff coming up. Now, when you take a look at examples 3 and examples 4, you may be able to do this on your own at this point. But one of the first things that I want to impress upon you is always, 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 the first thing after you write down the directions and look at what the question's asking for you. And again, in the digital world, you're going to write all this stuff out. You're going to draw a triangle. And that triangle, they tell you that angle C is the right angle, so that's going to go there. A will be here, and B will be up there. So that's going to be the very first thing that we'll do, is draw the triangle. And then we've got to figure out cotangent of A. And cotangent is going to be the adjacent over that opposite. So I need those two pieces. So I need adjacent over opposite. Now, based on where angle A is located, they tell us right here, this little a is 4. So that's the side that's going to be across from angle A. And C, our hypotenuse, they tell us that C has a value of 10 square root of 5. Now I need this missing value right here, this adjacent side right there. So right now I'm just going to call that B, because that's across from big B, from angle B. Now when we write that, so again, so the first thing right there, boom, draw the triangle and label all the sides. Second thing that we'll do is we will plug everything right into the Pythagorean theorem. So again, parentheses around your numbers. 4 squared plus B squared equals 10 square root of 5 squared. Now I've got another video that I want you to pause and take a look at on how to hook you up real quickly with squaring 10 square root of 5 squared. So you have to be really careful, because if you were to go to a calculator and just type in 10 square root of 5 squared, you will get the wrong answer. So don't do that, because I don't want you to get it wrong, because I'm going to put one of those wrong answers down there, fool. 4 squared, no problem, 16. B squared, we got to figure out. 10 square root of 5, what? That quantity squared. Watch the other video so you know how to play along. Don't just go to a calculator and go, Google says. I want you to be able to think and reason and do these things on your own, just in case the internet goes down for a moment. You can actually think without it, right? Cool, you're welcome. Now when you take 10 square root of 5, again, pause, go watch the video. I'm telling you, you're going to regret it. It's only 2 minutes. It's not even that long. You can fly through it. I'll link it down below this video, and I'll also link it in your notes for my students. 10 squared is how much? Yeah, that's 100. We know that. When we square 100, or when we take 10 and square it, we get 100. Times 5, that value is going to be 500. So we get 16 plus b squared equals 500. And then we do our arithmetic. B squared equals 484, and we know that b is going to be plus or minus the square root of 484. Now to figure out the value of b, all right, 484, a lot of times people will want to do a factor tree on that, and that's cool, but the numbers you pick for your factors, try to pick perfect square numbers. And I can look at this number, 484, and I know 4 goes into it. And it does 121 times. So a little bit different than a regular factor tree, because here, don't forget, we've got a square root around it, right? So make sure you're at the square root around that. Because when we take the square root of 4, we get a value of 2. Now 121 happens to be a perfect square number, which is very nice. And that is a value of 11. And 2 times 11, this was a number I wore all the time when I was a small child, and that was the number 22. So man, 22 was like my favorite number. I had this sweatshirt. I wore that thing everywhere. So I came up with some old pictures of that. Check that out. That's me and my grandma, one of my heroes right there. Oh my gosh. This was like back in the 70s. We lived in Germany. And so, we got a nice little pic there. Somewhere we were camping. I think it was either Lake Chiemsee or Garmisch or whatever. But then fast forward into the 80s, and here's a pic of us at our house with all my little siblings. So I guess my little sister Maureen was just born and everything. And then there's my sister Kate, and Joe, my brother Joe, is holding her. And then Brian, he still looks the same, man. He hasn't changed at all. And then there's me with my number 22 shirt. And this cute little thing over here that you can see in the corner, that's our dog, Narbu. Narbu is lost opposite, man. I love that dog. That dog, like, slept on my feet. It was the best, man. That dog was so cool. But anyway, I digress. So, cool stuff there. Little family photo moment there for you. So cool. So 22, because see, numbers are everywhere. So B has a value of 22. Now, back to our problem, which was figuring out the value of cotangent A. So we figured out the value of B was 22. So the very third thing we'll do is figure out the cotangent of A, and that relationship is not opposite over adjacent. It's adjacent over opposite, so it'd be 22 over 4, which reduces down to 11 over 2. And you know Musky's going to put a 22 over 4 as an option, as well as 4 over 22, or 11 halves, or 2 over 11. So you know those are going to be options, so please make sure you take your time and get that right, because I'd hate to see you get that wrong, because you either have fast fingers, or it's a common mistake. You don't get the ratio right. So onward to number 4, example number 4. Oh, such good times. I love my grandmother. Miss that lady. She was awesome. Now, in example 4, we got to find cotangent. And cotangent of theta is what we have to find if we're given the cosecant of theta being this ratio of 11 over 10. So cosecant, again, cosecant is going to be the relationship that goes with the reciprocal of sine. So sine was hypotenuse, or opposite over hypotenuse, so cosecant is going to be hypotenuse over opposite. Okay, so the hypotenuse over opposite. So when I go to draw this triangle, because again, that's always the very first step, draw your triangle, put theta in the lower left-hand corner of your triangle. And then with the relationship, 11 over 10, so 11 goes here, and then my opposite side is 10. So again, we've got to find this missing side because we got to find the cotangent of theta. And go ahead and do that. So that was step one. By now, you probably can do this on your own. So take your time, nice, neat, and tight. Go ahead and do the 3 steps. So 1 we've already done. Do the drawing. Step 2, go ahead and fill in the Pythagorean theorem, simplify that, and solve that. And then step 3 will be answer the question, get the cotangent ratio. So go ahead and pause, and then come on back when you're done, and let's check it out, see how you did. All right, so how did you do on that one? Hopefully, you came up with all the values that you see here going through this problem. Now, one of the things, if this were a quiz, let's go through how your points would be allocated. So the very first point, of course, would come from drawing the figure. The second point would come from correctly writing down the values that get substituted in to the Pythagorean theorem. Your third point comes from solving for b. And make sure you include that plus or minus with that, because you have to identify both potential solutions and, of course, getting the correct solution of b equals 20, square root of 21. Now, here, make sure you show your work. If you just go right from the very first point that you would get of 10 squared plus b squared equals 11 squared, if you just go right from there to b equals 21, like, yeah, you don't get anything with that, because that's what's called a bald answer. And ain't cool to have a bald answer. You got to show your work. You got to show your thinking. And that. So make sure that you do show that. And then your fourth and final point will come from correctly writing cotangent of theta is equal to square root of 21 over 10. Now, a couple of words to the wise here. A couple of words to the wise. When you go through and do this, if you just write cotangent and then 21 over 10, like, that doesn't get no points, yo. Not happening. Cotangent of what? So you have to make sure that you include the angle. The other thing that you could do, or even if you had square root of 21, still wouldn't get it. The other thing that I've seen students write is they'll say maybe like this. They'll just say theta equals square root of 21 over 10. So it's not that either. So when you write your final answer, it needs to be written just like Musky wrote right there. Cotangent of theta equals square root of 21. And make sure the square root is clearly only in the numerator. It doesn't extend down and look like it's in the denominator at all. All right, so that is it for this video. Thank you guys so much for watching, man. I appreciate it. I love you guys. I hope you have the most amazing day ever. I mean, you traded your life for today, man. And one day of your life is going on right now. Why not make it the best day ever? All right, I'll catch you later. Peace out, Cub Scout.